Okay.
Anyone watch Word World?
Who?
Word World?
Yeah.
All right, guys. Rectangle models backwards. So last week we learned how to use area models to distribute, right? This week I'm going to mix up the numbers a little bit and we're going to fill these out backwards. But before we do that, I want you guys to kind of go through and talk me through what we labeled. So last week the first number, or group of numbers, represents our what?
Variable.
No, what's that first number or group of numbers represent on our area model?
A constant, that's the number.
Say it again. Height. So it represents our height. The second number or group of numbers represents our length. So what don't we know about this?
It's width.
We don't know the length, right? Length. So we don't know the length. So we're missing this length and this length. However, we have this information. What is that information? Once we found area equals height times length, we found the what down here?
Width.
No, what do we find after we found that? Height times the length, and we multiplied it to find the total area. So what was the answer that we found down here? The area. And what was the answer we found in this rectangle after we took that height times length? Area. And then what did we do with the area? We brought it up, right? So this here actually represents our total area, okay? So if I would distribute this out using my area model, I'd end up with this. So I need to find my missing numbers. I need to find my missing length. So this here actually represents the area.
Okay, so I got it.
Okay? So what's the area of my first rectangle?
8C.
Okay, so I'm going to put my area, remember I always put kind of towards the bottom, equals 8C. What's the area of my bottom right rectangle going to be then?
Equals 10.
Okay, so if we think about it then, we have the height of each rectangle, correct? Okay, give you guys a second to get that in there. So I know the height of each rectangle is 2. What I don't know about each rectangle is the length. So that's where we have to come up and figure out what the length is going to be. So I think to myself, 2 times what will get me to 8? 4.
4C.
Now, if I just take 2 times 4, I'm only going to get 8. So that 4 is actually going to have to be a 4C. So the length of my first rectangle is 4C. So if you notice how I showed my work, remember how I said we're always going to do height first times length? Once I found what that length was, I plugged it in and I brought it up to label my area model. So then I come to my second rectangle. My height I know is 2, so 2 times what equals 10? 5. So I bring that up to show that for my other length. Okay, so I went ahead, I found my length, I labeled my rectangle area model. So then what do you think you guys fill in the blanks there?
Let me just... Pardon, sorry about that.
Oh, I was just.
Can't talk right now.
Okay, so what do I do with these numbers here?
Multiply.
No, what do I do with these numbers? What do my directions say?
Oh, film.
So what goes in this blank?
2.
Okay, 2 is my height. My height comes first, then what comes next? My length. So it's my first length that I found. 4C. What's the length that I found my second one? So it's going to be my second length that I put in here. So what's the second length of my area model? 5. So that's all you're doing. Okay? So all you're looking at, your area model. Remember last week? So last week, take this back part away, right? Last week I gave you the height and the length, and you found the total area. So then you put the total area as your answer. This week what I'm giving you is some different information. I'm either giving you the height or the length. That's why I always said, hey, height always goes first, then length. And then I'm going to give you the total area, and you have to find out the missing information. Okay? Now remember, this skill is going to build upon for when we start factoring, okay? All right, let's take a look at the second example here. So the second example is very similar to the first example. We're going to fill in the blanks. So what numbers up there represents the total area of the rectangle? What numbers up there represent the total area of the rectangles? Maddie?
15D and for 35.
Yeah, 15D and 35. So 15D is going to represent the area of my first rectangle, right? So I'm going to put that at the bottom here, 15D. So what's the area of my bottom right rectangle? 35. All right. So I labeled part of it. Now I need to come over to the left side. What does this 5 represent?
Area for the height
The height. So what don't I know?
with the top length are.
The top number. What represents the length. Okay? So if I know the height, I can go ahead and fill the height in. 5 times something to get me the total area. Okay? So 5 times what is going to get me to the area of 15D? Maddie?
3D.
3D. So that represents what on my area model?
These 3D.
Represents what?
The length.
The length. So I'm going to label that on up. Okay? So I know the height of my second rectangle. Now I need to find the length of my second rectangle. So 5 times what equals 35, which is my total area? Maddie? 7. So 7 is the length of my second rectangle. What do I do with this information I just found?
You're gonna put it up on the
Oh.
top 3D plus 7. Or put it in the box.
And that's it. Where'd you go?
Does it get any harder than this?
I don't know.
For today.
No.
I have a question.
Nope. I don't think so.
I have a question.
Yeah.
I am really stuck on how did you get 30 and
So if I know,
7.
how do I find the area? No, that's an excellent question to ask. How do I find the area of a rectangle? What's my formula I use? Okay, so I use area equals length, or we're going to use height times length, right? Because we always want to do our height first. Okay, now once I multiply these together, I get the total area, right? So if I know what the height is of something, and I don't know what the length is of something, but I know the area, I just have to think to myself, what the height times what will equal the area? Okay? Does that make sense or no?
Yeah.
Okay, you're gonna work this next one for me a little bit. Okay, so let's look at. Oh no, it's not any harder. It's not any harder. So example number 3, you're gonna put 12x squared y plus 18x or xy squared. What do you think that these two terms here represent?
The area equals
The total area, okay? What does this represent?
the height.
The height. So I'm just writing it out backwards this time. So instead of doing height times length equals area, I'm doing area equals height times length, okay? So if this represents the area of each rectangle, what's the area of this first rectangle here?
12.
Keep going. So that's the total area of this rectangle. I'm going to put equals 12.
Okay.
Okay, right? So then what's going to be the area of this right rectangle?
Oh, equals 18xy 2. Carrot top 2.
Okay, so because it's the total area of the rectangles, I put it at the bottom. I put equals total area.
Yeah.
Now, this represents what?
The height.
The height. So if I know the height of this rectangle here, I'm going to go ahead and fill that in. What don't I know about this rectangle, Logan? I know the height, I know the total area. What don't I know?
The length.
The length. So that's what I'm trying to figure out, right?
Yeah.
Okay, so let's think about it. We've got to figure out what the length is. So I have to think to myself, 6 times what will get me to 12? 6 times what gets me to 12? 2.
So, yeah.
And if you don't know that, you guys, just take 12 divided by 6. Okay? Now, I have 1x up here. My total area, I have 2. So if I go from 1x to 2x's, how many x's does this guy have to have? 1. So 2x. And we look at our y's. There's 1 y up here. There's 1 down here. So does this need any more? No. So the length of that rectangle is 2x. Okay. Now let's find out my information for this next rectangle. Do I know the height of this rectangle?
No.
Yeah.
Yeah.
Yeah, because the height of this rectangle is the same as this one, which is,
6x.
okay, so now I need to find the length, right? I don't know what the length is. So I think to myself, 6 times what gets me to 18? 3. Okay. And then I have 1x up here and 1x down here. So do I need to multiply it by an x?
No.
Nope. Okay, 1y up here, 2 y's down here. 1 y. So the length of this rectangle is 3y. Okay, now I'm ready to write my final answer. So area equals, okay, so my area equals what, guys? What's my height?
12,
What's my height?
6. Oh, yeah.
6.
6x, 5.
Okay, now I take my height times my length. So what am I going to put after my height?
The 12
Times.
Oh,
So
yeah.
how am I going to show times by? The dot? Parentheses. Let's use parentheses. And what am I taking that 6xy and I'm multiplying it by?
2x plus 3y.
Yeah, I'm taking it by 2x plus 3y in parentheses. So there's my final answer for that particular area model.
Last one.
Will you guys do me a favor real fast? Will you do me a favor real fast? Just where you have room, on example number 3, remember in our opener today, I had you guys factor the terms? Factor those terms for me. So let's factor those terms real fast. I'm going to do it in, what color haven't I used yet? Let's do it in this maroon color. So what are my numbers? What are my factors for 12?
2 and 6.
Okay, and then for 6?
2 and 3.
And what about for 18?
2 and 3.
And for 9?
3 and 3.
Okay, so if I make my list real fast.
Well, I guess you would circle all of them.
Mm-mm.
Oh, sorry, except for 1.
What do they share?
A 2 and a 3.
Okay, so the greatest common factor, what's 2 times 3?
6.
Okay, look at your variables for the terms. Do they both have an x?
Yeah.
Which is the smallest?
18.
Just the one to itself, right? Do they both have a y? Do I use y by itself or y squared?
Y.
The greatest common factor, what do you guys see about it?
So, like,
It's the height. So we're actually, the reason why we started with finding the area models, using the area models, because we're going to go and start factoring. Our next lesson next week is going to be using the greatest common factor to factor. So that's why you need to find out or know how to get the greatest common factor. Once you get the greatest common factor, you guys are going to be able to factor the polynomials, okay? It is a lot of factoring. Factor, 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 factor. It's our whole unit. Okay, let's take a look at this last one here. Go ahead and write this example problem down. So I have 54a cubed b squared c minus 63a squared b cubed.
what's that even around here?
50. And it's 34. Sorry, I've been doing bad about putting that up where you guys can see it.
And we have 9.
All right, so let's look at our information. What information is given to me? How do I know that this does not represent my length?
The subtraction sign?
No, how do I know that these two terms here doesn't represent my length? Because my length is always surrounded by what?
Oh, it's not by this.
Parentheses. And I don't have parentheses there, right? So because there's no parentheses there, there's two terms. How many rectangles do I have? Two. So this is going to actually represent my what? My area. So what's the area of my first rectangle?
54 cubed square.
And what's the area of my second rectangle?
Negative
Negative. Take that negative with it. So negative what?
63 a squared b cubed.
Good. What does this number represent?
Is he
What's this represent?
a
What number is that?
What number is that? What is
Oh.
the height? So I'm trying to find the length again, right? So if it's the height of this rectangle, I know that it's the height of this second rectangle. So my height, so I like to go ahead and just fill my information in. A squared, b squared, times something. And then I'm going to go ahead and put that height in for my second rectangle, 2. Okay, now it's time to find the missing length. Okay, how do I find my missing length? What thought process do I use here, Maddie? Okay, what does that equal? Okay, so I know if I take 9 times 6, I'm going to get 54. Now I have to worry about my variables. So I have a squared and a to the third. How many more a's do I need?
Just like A1 and then
Yeah.
C.
And then what about b? Do I need any more b's?
No,
Nope. And then I don't have any c's up here, but I have one down here. So how many do I need?
just one.
So my length is 6ac. Good. Okay, let's find the length of my second rectangle.
Also, I thought you were 6 foot, with a B.
Oh, was a b? I'm sorry. So 9 times what equals negative 63? 9, yep.
7B.
What kind of 7? If I'm going from a, yeah, it has to be a negative. If I'm going from a positive number to a negative number, I have to make that a negative 7. So 9 times negative 7 will get me to negative 63. Yeah, take that negative with it. Now,
Negative 7.
do I need any A's?
No.
Do I need any B's? How many? So the length of this rectangle is negative 7B. So the area, because this is the area of each rectangle, equals, what's my height?
A squared B squared.
Times, because remember height times length, so it's my length.
6 AC. Minus 7B.
In parentheses, and there's your answer. Now, what does this number, I know I said, you guys know that this represents the height of my area model, but this number is actually the what of these two terms? We found it on the previous example.
I forgot what it is called.
It was our first lesson, second lesson that we learned last week. It's the,
Greatest common.
yeah, it's the greatest common factor. Good.